Hello, this is Mrs. Scarple, and in this video I am going to show you how we can use rectangle diagrams to help us factor trinomials. I know these first two examples aren't trinomials, they're a polynomial with 4 terms, and I'm using this to help you understand how those diagrams that we were using for perfect squares can be used to think of as rectangles instead of just perfect squares. So I'm going to start by drawing the diagram we are used to seeing. So we have our x by x diagram, which has the area x squared, just like the first term of this polynomial. Then I see that we have a 5x. Well, that means I need to have a region of 5x added to my square, but I also have a plus 3x. So here's my region of 3x. And then we have the 15 units. So to get this 5x, we would have needed to take 5 and multiplied it with x to get that. So we were adding 5 to one side, and to get the 3x, we had to increase x by 3 so that when we take 3 times x, we have an area of 3x. So as you can see, each region of our diagram has a place within this polynomial. So when we write the expression in terms of its dimensions, I would write this as x plus 5 times x plus 3, or it can be written as x plus 3 times x plus 5. It does not matter the order you write the factors, because it will give you the same result no matter what. So let's take a look at this second one. Again, starting with my x squared, which we know is found by multiplying x with x, adding 4x to one side, adding 6x to the other side, and including our units of 24. So if I'm going to have an area of 4x, that means I had to increase one side of my square by 4. And if I'm going to have an area of 6x, that means I had to increase one side of my square by 6. And we can verify that 6 times 4 does give us our units that we were given. So we can write the representation as factors, or as the dimensions of our diagram, as x plus 6 times x plus 4. In these expressions, we are only given trinomials. We're only given 3 terms. What we do know for certain is that we have an x squared on each one, and we know how many units each one has. We're not looking at separating the 11x because we know that these aren't necessarily going to be perfect squares. They can be rectangles. So we're finding 2 binomials that will multiply to give us this trinomial of x squared plus 11x plus 10. This process is called factoring. So what we need to do is we need to think about how much is added to x so that we can get the middle term of 11x, and we can get the units of 10. Well, we know we have to multiply to get the 10, so I'm off to the side going to write my factor pairs for 10. That's 1 times 10 and 2 times 5. Now I know that what gets added turns into one number x plus another number x. The two numbers that I choose have to add to give me the 11. I see that I have 1 times 10. I know that 1x plus 10x will add to equal 11. And I also know that a positive 1 times a positive 10 will multiply to give me my 10 units. So this factors as x plus 1 times x plus 10. Looking at the second one here, starting with my x squared that I know I have, including the units, which once again are 10, so we can use those same factor pairs that we looked at before, to determine how much needs to be added to each side to equal 7x. Well, 1 and 10 we saw in the previous one add to give us 11. 2 and 5, 2 plus 5, so 2x and 5x will add to give me the 7x, as long as they are both positive. And 2 times 5 is 10, which is the number of units that we have. So this factors as x plus 2 times x plus 5. Third example, start with your x squared, include your units, the units tell you what you're looking for factor pairs of. So for 8, the factor pairs are 1 times 8 and 2 times 4. We are looking for the factor pair that when added gives me 9. Well, that's going to be 1 and 8. 1x plus 8x will equal 9x. 1 times 8 will equal 8. So this factors as x plus 1 times x plus 8. And for the last one, we have x squared, we have the 8 units again, so we can use the same factor pairs we were just looking at, but this time we're looking for the pair that adds to 6, and that would be 2 and 4. So 2x, 4x, we're adding 4, we're adding 2. When I multiply those together, I do get a positive 8. So this factors as x plus 2 times x plus 4. Do not be afraid to list out your factor pairs off to the side so you have it as a reference. Do not be afraid to draw a diagram so that you can see what numbers you have, and to make it easy to check to make sure you're going to end up with that initial trinomial that you are factoring. And this concludes the video on factoring trinomials, part 1.